できた？する
As usual, I am not late, I am not early. I arrive precisely when I intend to. Good evening, everyone. So I did have a bit of a, experience with this machine. I realized I sort of messed up. I used motors except for, well, this one has the wire on it, but I used motors that didn't have wires and that didn't have the matching crimped connectors, because I thought what I was just going to be able to do was to use these standard DuPont connectors and just plug those in the motor. But the problem is these are 2.54, so 1/10 of an inch pitch, and the connectors on the motors themselves are 2 millimeters, so they don't fit. So I had to borrow a few of these motor wires from another printer that doesn't need them right now. So that's sort of why I'm late. Also, preparation and stuff took a bit longer. But today I think we should be able to finish the mechanics of this thing. Don't expect it to be printing today. It still doesn't have any firmware on it. But like power supply mounting, yeah, that's going to need a pair of holes in there. Power supply mounting, wiring, that's going to be a bit of a tedious task. Because obviously this is just not really routed yet. Also, the stuff that's on the frame isn't really there yet. So that's going to... Wow, Nightbot already added. So that's not done yet, but we're going to be doing that today. Also, heated bed is going on. Again, let me just show you what we have here. So this is obviously a heated bed without any wires attached. So that's going to see some soldering in a second, or in a second later today, hopefully. Yeah, but that's the plan. Finish up the mechanics of the machine today and work along the official manual as much as possible. So I'm thinking the stream should be good to go. Maybe just double check. 'Cause I did publish it pretty late, but yeah, that's good. Also, toms3d.org /dolly, the official page to list all the parts and all the stuff you need. That's gotten a bit of an update today to reflect the printed parts, so they are all listed now. I've also put together a zip file of just all the printed parts that I used here, and yeah, that should be a good guide as to what parts you need, which ones you should print, which ones you should use the modified ones for, and so on and so forth. How do you wire a heated bed up? We're gonna see that in a minute. I'm hoping I think I have a thermistor for that somewhere. Yeah, it came with a bed. I'm hoping I didn't throw that out. So yeah, let's check what the manual says. What's up next? Ah, yes, spiral wrap. I did get some spiral wrap. I don't think that is, I don't think this black spiral wrap, I have a clear one. I don't think that does too much in this case. You could use zip ties just as well, but before we do that, we are going to need to add an extension cord to the fan that we use. So this is the, let's see, there switch. Yeah, so that's the wiring from the extruder poking out here. And we put a little connector on it. On the part cooling fan. Why is that so locked up? Who did that? There we go. You put a little connector on the part cooling fan last time because the wire was too short. Anyways, so we will need to extend that, and I think I've got just the thing to do that. I had it a second ago. Yeah. Right, so the wiring kit, the $3 wiring kit that has like the 14 wires and stuff in it, it comes with these 3-pin connectors. Let's actually switch back. With these 3-pin connectors, green, black, and red. Those are intended for the end stop, but of course you can use them just as well for anything else. And what I'm just going to do, because they have the standard DuPont connector on both sides, you can pop the pins out and put a smaller or larger connector on there. And actually, in that case, we don't need... Let's check with the ramps. Yeah, the ramps does not have... Look at that. So the ramps doesn't really have a fan output. It has the only 3 power outputs it has are these 3 up here. So that's hot end heater, part cooling fan, and heated bed heater. That's it. So yeah, the hot end fan is going to be always on. That is going to be wired directly to the 12-volt input. And yeah, the part cooling fan doesn't need a connector because it's going to go into these screw terminals anyways, and those are just for plain wires without anything on them. So $3 for 14 wires, yes, but they are crimped. They're nicely done. I actually paid $10 for the set because I bought it from Germany because I needed it, and the one from China isn't here yet. So yeah, you can pay as much or as little as you want for these. Come on, I should use like... No, okay, yeah, there we go. I should use tweezers or something for this. So you can remove these pins. You can just break the plastic housing. You can remove the pins. Is the stream actually smooth for everyone else, or am I just seeing the stuttering? Yeah, so you can take these out, and then you get to the crimped pins right there. These are just the bare ones, and they fit in any other connector. The only thing is we need male ones. We need the pins and not the female receptacles. So yeah, whatever. That's trash. And this side's gonna come off as well. The green one we do not need. These 2 come off. I could have just used, at this point, I mean, I could have just used any other regular wire. I know. But yeah. There's 1. There's 2. And let's just crimp some male pins on these. Yeah, unfortunately wiring is just bad. Wiring is cutting wires to length, crimping on connectors, dealing with connectors, routing wires. It's not a very enjoyable process, at least not for me. It's not like something I want to be doing, but it's just a part of the process, and if you do it right, you hopefully are only going to have to do it once. And, you know, seeing the result and seeing how well everything fits together and how neatly everything is routed in the end, I mean, that's a reward in its own. So someone was saying last stream that they were very slow with crimping. I mean, I'm not the fastest or bestest crimper ever, but this sort of stuff is pretty okay. It's bearable. So as usual, well, let's compress these a bit so they fit a bit more easily. There's 1, there's 2. By the way, how did you guys like the intro music on the intro or starting soon screen? That's obviously a different one than the last time. 1, 2, so these are in, but they are not in focus. There you go. That's the same housing that you use for the female pins, and the male ones just poke out in the front. Stream is extremely laggy. Interestingly, now it's smooth for me. So YouTube. Well, anyways, there's that. Did I make the music on my own? No, I did not. The usual music is by, come on. Yeah, by David Cutter, who publishes his music on SoundCloud for, I think, YouTube creators or anyone to use. Casey Neistat uses them, for example, uses the tracks. Today's track was by Tokyo Machine. It was Pixel, which is released on Monstercat, and Monstercat has a YouTuber's subscription where essentially they you pay a fixed monthly fee and then you get to use all the music that is released on Monstercat as much as you want. Nope. Music is not David Cutter today. Not today. I know I'm making it hard for my mods today. Use some Captain on the plugs to secure them. No, I'm not doing that. I'm actually just zip tying them to the other wires. One in front, one in back, and there is no physical way that the, that this is going to come apart. The DuPont connectors do not have any sort of thread locking, so if you use these in a moving configuration or anything, then you will need to take care of yourself that, come on, that they don't come loose. Okay, get that tight. Can I review the diamond hardened sometime, maybe? Eventually. Once I get everything else done that I want to review and make content about. What is the crimping tool? SN28B. That's the, obviously, German import guy. SN28B, that is the crimping tool that I got, and it was sold specifically as a DuPont crimping tool. It's called for non-insulated terminal, whatever. Cheapo, Amazon, yeah, eBay import. It's like the generic type of crimping tools you can get. Okay, so that is done. Now we do have the connector in there, so. But if you move it around, it's pretty good. It's pretty stable. It's not going to kink. That's the main thing to watch out for here. Why did I choose the DuPont connector? Because I don't like soldering wires together. It creates a weak point, just like these connectors. It's slower. It's messier. You need to put shrink wrap over. I don't know. I just like the connectors a bit better. Shy Perednik sent $5, and he was asking about the bridging. Oh, why is that so dirty? The bridging technique used in some of the 3D printed parts here. I think I did explain it again, but obviously I'm going to keep the camera on these parts. But when you are printing I might just as well cut this guy a bit short. When you're printing a counterbore in a 3D printed part, and you have, starting from the bed surface, from your print bed, you start with the screw head that has a large diameter, and then have to, step it down to the smaller diameter through hole for the screw, or for the thread itself, then you will end up with that ring of material around the thread that does not have any support underneath. So that's why you use a single layer of material, a single layer of, you essentially put one solid layer through over the counterbore, and that allows the 3D printer to bridge on top of it, or to use it as a bridge and then print the through hole for the thread on top. Hope that does explain it. Also, thanks for the $5 tip from Colin Klupka. Series of stream. Yeah, I'm sort of feeling bad for streaming this much and not making as much regular content, but it's like, it's the regular rush during the day, just getting stuff done around the house and doing all the other administrative and accounting, whatever stuff for obviously business. And then in the evening, it's like, yeah, here you go. It's a 2-hour stream. That's all I'm going to publish for today. I feel bad about that. I don't know. I might take a bit of a streaming break on the weekend. Usually it's the other way around, where I publish or work on regular content during the week and then stream on Sunday. But I think I might actually do this the other way around this time. I'm actually seeing a lot of people saying, yeah, they enjoy the stream, which is weird for me because usually it's the other way around. Usually it's like, yeah, people are saying, stream, it's live, it's not edited, it's not scripted, And now it's sort of the opposite. Weird. Plastic hose, what is this called? Like spiral wrap or something. Alex, wait, is the name Alex? Yeah, Alex is asking about the plastic parts potentially melting on the hot end down here, which I can maybe, yeah. So there's the heater block. I've got my finger on it. That's the nozzle. That's the heater block, and the plastic parts back here are fairly close. The good thing is there is a bit of airflow, so the parts are getting cooled faster than they heat up from the radiating heat. And also these parts are ABS, so they aren't gonna melt or deform as easily as others. You should print those cable management chain things. Well, drag chains, I do have a video planned, as I do on so many things, where I try to explain like drag chains and stuff. I did look into the entire drag chain topic a bit more when I modified my what used to be a Mendel 90 into what I now call the Mendel 9000, and I actually looked into like endurance, durability ratings on EGOs, on cables from EGOs that are specifically made for drag chains, and like bending radiuses and that sort of stuff. And it turns out, you have to do a pretty large drag chain and a pretty large radius to get any sort of decent lifetime out of these things, even when they are real drag chains or real drag chains with the proper wire routing and real drag chain wires. So yeah, will this be printing today? No. Don't get your hopes up. Okay, so I'm thinking I should like fix this somewhere around here, maybe. Right there. It might droop down a bit too much, but we can always rotate it. Yeah, looks okay. Looks okay. So yeah, we're just going to leave it at that for now. This is going to get zip tied to the frame, maybe with a few extra holes. People don't like it when you drink or eat on stream. I'm fine with that. Even is saying Google didn't warn him about the stream that it was up. I might have done that wrong, maybe. I did click start streaming before actually sending the stream public. That might not have shown up for a few people, but oh. Who cares about viewer counts, right? I'd rather have a nice civilized stream with respectful people than the craziness that was the Monday stream. Yeah, but I mean we've got a decent amount of viewers. That's okay. Okay. Steve M, if no notification, if YouTube hasn't notified you, you might not have that bell enabled next to the notify button. then YouTube does sort of an auto sorting and auto prioritization thing with the content you're subscribed to. Hey Simone, by the way. Yeah, that's not what I wanted. This is what I wanted. So yeah, just why was that open? I don't know, but Simone Fontana, one of the mods today, awesome designer, doing like Overwatch and props and pretty much, you know, some of the coolest stuff you can 3D print. Check out his work, become a patron for him, and yeah, get some of the designs and print them yourself. Cool, finalizing the extruder. Check free movement, we did that once. Satisfied with the organization. Yeah, we're satisfied. So next step is LCD assembly. I'm not building this machine with an LCD, I'm building it just with a, wait. Was I on the wrong? Was I on the wrong screen cap? The wrong window? I don't know. It's fine. LCD mount. I don't have an LCD for this machine, so it's not going on. So I'm totally skipping that. Power supply and heat bed assembly. So this is sort of the step where the... This is the step where we sort of deviate from the assembly manual. Because at this point, with the power supply and like the electronics mount and that sort of stuff, we don't really, and also the heat bed, because we, you know, this is a different heat bed, obviously. We can't really rely on the manual anymore. Okay, so I guess from this on out, yeah, I'm pretty much going to be winging it. Just to catch up on that, you might have seen the tracer gun on the back here. Obviously, Germany gun law is pretty strict, so I did paint the, what's this called, the nozzle? Whatever, orange. My hands are a bit too large for this, but a pretty awesome model, and very enjoyable to print, because it's not a hard print, it's just a good design. And also yeah, I try to rust these, but I don't think that worked too well. Let's see, there you go. There are a few, oh yeah, these did rust. So there are these, come on. Yeah, this round part here, this is starting to rust. This is Protopasta iron filled. Also, I think this is called the pommel down here. This is also the iron fill, and I did try to rust it, but that one didn't corrode yet. Yeah, really quick print actually. All printers are going on full blast. I did print this like the day before I went to it's like a semi-TV live stream show thing in Munich, and I wanted to print something, so I printed that out. So yeah. What is the material? Yeah, like I said, from now on, we're winging it. We're not relying on the manual anymore. What is the material? This is rigid ink. Someone else asked yesterday, so I still haven't looked up. This is rigid ink red pearl. So it's a slightly metallic look. Donations, tips, 20 Swiss francs from Sandro. Thank you for that. And on stream tip, Alan Schmidt, €3. Much appreciated. Okay, now what we need to do is power supply over here. We need some electronics over here. We need a heated bed and no bloodshed today. And then wire everything together. There we go. So, what filament am I going to start with in this? Probably a PETG, because that's like the easiest to print. Right, heated bed. Okay, so the heated bed has, and again, this is an aluminum one. This is a very thin aluminum one. This is not flat at all. I am not going to put a glass sheet on top. I'm not going to, bother trying to get this flat. But yeah, obviously we are going to need to find a way to get stuff to stick. Yeah, to get 3D prints to stick on this. I'm thinking I'm just going to use 3D lag or what's it called? What is this stuff called? Adhesion spray, printer fix, yeah, or 3D-Ease or Wolfbite or anything like that. I might put a PEI sheet on it. I do have a few spares. That's probably going to be the ideal one. We'll see. But for now, this thing needs to go on the frame right there. Yeah, super thin. It bends really easily. It's probably not going to last. I'll just try. But since we do have bed leveling, and I'm going to configure this for mesh bed leveling, it's not going to matter that this isn't perfectly flat. But before we do that, so yeah, 1, 2, 3. So on the back, you usually have like this table on how to wire it up for 12 and for 24 volts. And you have these 3 pads down here, these in the center, or for an LED typically. And then obviously in the center, the LED, oh, my phone's buzzing, okay. And you get 1, 2, 3, and if you're wiring it up for 12 volts, pin 1 goes to positive and 2 and 3 go to negative. So that's positive and these 2 are negative. So let's grab a soldering station, some wire, and let's wire this thing up. Bum, 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 bum. Just 1 second. Soldering station, solder, arc, why is it solder? This stuff is dusty. You can still hear me, right? And like this over here is the room that I posted on Twitter today, which is the room that's going to be a hand printer sometime soon. That's an awesome project. This solder there. We're back. OBS Studio, as nice as it is, it's not 1000% stable yet, or it might just be the laptop being not powerful enough to handle everything. Whatever, so some soldering. Should have brought flux. Yeah, these are tinned, these don't need flux. Music made it crash. Yeah, I come back and it's like the thing's gone. Okay, so this is 0.75 millimeters squared wire, is it? Probably. 1.5. I don't know, it's pretty thick. But again, pin 2 and 3 are going to negative, which I'm going to use the marked wire for. So these always have, I'll show you these always have like one strand that has these ridges on it just to mark one, and the other one is smooth, so you can tell them apart. Zoom range. And a completely dysfunctional autofocus. There you go. Oh, you can actually see that. So one side has these ridges in it and the other one is smooth. And I don't know if there's actually convention on how to, assign these, whether the ridged or the smooth one or negative or ground or something. But I just usually like to wire them up where the ridged one is the negative, just to keep it consistent. So yeah, I'm gonna get you guys a good view of my shoddy soldering that everyone's gonna complain about. But remember, this aluminum stuff is pretty hard to solder because it is aluminum at its core. It is very good at conducting heat, and this layer between the actual copper traces here and the aluminum on the bottom is fairly thin, so it is going to wick away a ton of heat. Also, this copper wire is also going to wick away a ton of heat, so I'm using a very thick tip. And yeah, use flux. No, these are tinned. I don't use flux. Look at how beautifully that is going on. I'm gonna give it a second to reheat. It's 0.75 okay. In theory, yes it is. But as usual, theory and practice are always two different things. So I'm not gonna give advice on that. Yeah, this thing is very thin compared to the Mark 42. But again, since it is using auto bed or mesh bed leveling, I don't think we're gonna have that much of a problem. Yeah. As far as the, how do I strip this best? As far as the Mark 42 goes, whether that's going to be available or not. So some guy just wrote me an email earlier today saying he's going to have a crowdfunding campaign on that exact Mark 42. Well, not that exact Mark 42 bed, but a Mark 42 bed. And that might be available pretty soon. The exact one I have does not have a release date yet, but stay tuned for that. And obviously, this bed is more or less a temporary solution. It's gonna work, the print is gonna work fine with it, I hope, I think. But I am gonna put the Mark 42 on here afterwards once we're done with the build, so I'm not going to be using this one too much. Link for the crowdfunding page. It's not live yet. It's I did get an email about it that it is gonna happen, but it is not available or for public view yet, so I can't really share the link yet. But you know, next week or so. We're gonna know more, and I am expecting a lot more vendors just to, you know, push into the market and try making these or start making the Mark 42 beds. Thing is, it is fairly hard to get someone to actually guarantee the sort of flatness that you need. Okay, I do need to let this one heat up a bit, and that's like the hard work part of it. You know, finding a manufacturer that will make it as flat as you need it, and be able to make, you know, as many as you need that flat. Because I mean, it's not hard making 50 and like picking the two best ones and showing those off as like golden samples. But like the hard part is making that consistently and delivering that quality every single time. Okay, that should be, yeah, that's good. That is good. It's not the nicest. That is not the nicest solder joint I've ever made, but as many things in this 3D printer, it's good enough. It's gonna work. And I should open up a window in a second. This is non-acid, non-corrosive, no clean flux, lead-free solder. I'm not a fan of lead solder, even though its solder is nicer. It's just, you know, I'm not the most anal guy when it comes to like keeping your workspace well ventilated and you know, adhering to all the safety practices when it comes to soldering. So I'm not a fan of just lead fumes in the air and like lead free and non-corrosive stuff is my compromise in that case. Actually, like positive negatives doesn't even matter on this thing. It's just a big resistor. It doesn't have a positive or a negative. What is wrong with the bed and why am I changing it? Well, it's smaller than the Mark 42. That's one big reason to change it. And it also doesn't have the calibration points for automatic or automated XY squaring, because it is just that continuous aluminum surface. Okay, I'm gonna open up a window. And also it's thin and flimsy and it's thin and flimsy and might not last too long, but as I think I said that in the scripted video, if this turns out to be not flat enough or warps or does some other crazy stuff, we can always put a 3mm aluminum sheet on top and that's just gonna work. Was the dude from Norway? I have no idea and I'm not gonna look it up right now. Okay, so that can go on the machine actually, more or less. Well, we still need a thermistor, but that's gonna fit on here. And where's the electronics gonna be? This side. Okay, so this way around, and that's actually working out beautifully. Okay. Maybe like that out the back, and then I can zip tie it to the frame here to give it a bit of strain relief, because you don't want the solder joints to bend back and forth constantly. Do you have a teleprompter showing me the comments? No, but I do have a 32-inch flat screen TV zip tied to the tripod that camera is on, so I can keep an eye on the comments. Let's see, thermistor. I did have a thermistor with this guy. I think I might have misplaced it, or the guy didn't send me one, but I do have. Well, do I want to use this one? Oh, I guess I can. Yeah, it's gonna be the same thermistor I'm gonna be using for. Surprise! It's the same thermistor I'm gonna be using for the Mark 42 bed anyway. So let's stick with that. Pre-soldered? Is it pre-crimped? Nope. Open leads. Open leads. So that's going to be some more crimping, but that is okay. So the bottom here, use the Bosch for what? What about the middle of the hole in the middle of the bed? Yeah, obviously there is a hole straight through the bed here. Which, you know, is usually like the spot where you'd mount the thermistor. But the idea is, as soon as I put some Kapton tape or PI or whatever on here, as soon as I put some PI over this, the hole in the center here shouldn't be visible on prints at all. So I'm okay with that. PCB traces with the bed bolts. Yeah, I've heard those horror stories where traces of the PCB actually shorted out to the aluminum surface on the back or to the bed undercarriage and caused a fire and that sort of stuff. So I'm just taking a peek here, and it looks like there is no trace on this corner. There is a trace, but not as close to this corner. There is one over here as well, and one over here. So these three corners do have traces fairly close to the screw holes, but I'm thinking I'm actually not, since I'm going to bolt this down pretty hard, you're going to see that in a second, I'm not going to have like a moving spring-loaded wash on here, so it's not going to rub through. Yeah, so this guy, should I put it in the center? I guess I should. Yeah, then zip tie to the cables back here. Let's do that. Oh, the bolts in the middle of the bed? Yeah, I can. But even this, if those scratch through, it doesn't matter. I'm just going to leave it enough space so that it's not touching these. Captain tape. Also one of the things you should have. You know, if you're old-time rapper, you are going to have a good supply of Captain tape. But it's just something, one of those things that is just super useful for having around the shop for DIY projects. It's a nice high temperature tape. Come on. And that is not how you tear it off, obviously. This knife is not pointy. That's what it is. Let's put it in the hole. There we go. Yeah, this stuff sticks until like 200 degrees easily, so it's good if you're doing hot air stuff. You can just insulate some parts with it. It's nice stuff, and obviously you can get it in all different sizes, and it's really thin and it insulates pretty well. Okay, and then these two can get zip tied together. That's gonna be beautiful. Yeah, no experiences with 3D printers. This is probably not the ideal project for you. It's not the easiest way to get into 3D printing. You're gonna learn a lot. That's like that's one of the upsides, but of course building a 3D printer from scratch like this isn't the easiest thing ever. So you are going to learn a lot, but you must be willing to learn, and you must be willing to problem solve if this is going to be your very first project. Okay, that is looking good. So we've got the thermistor in the hole in the center, right there, just, you know, sitting right in there. I don't know how well that's going to pick up the temperature. I'm going to put a few extra layers on the bottom just to insulate it a bit better. This is Kapton tape. And I do have a piece of like aluminum tape that should conduct the heat towards the thermistor just a bit. And this is the thicker aluminum tape. I will retest the inductive sensors with this thicker tape. As it turns out, the tape I was using was very thin, was quite, you know, a thin sample of aluminum tape. And this one feels a bit thicker. This is almost like aluminum foil with adhesive on the back. So supposedly this works better for triggering inductive sensors, whereas the one that I was using just didn't do anything. This one should trigger them, and you know, that's going to be a rerun, a rematch for the inductive ones. Yes, the regular Mark III. I don't know, the Mark IIIs are thicker, but then again, this guy was only like $6 or something. I would recommend getting just the 3mm aluminum one if you can. But then again, I am trying to build this thing cheaply. What's the name of this tape? Kapton, Kapton, which is a DuPont brand name, so the official name is polyamide. but typically you are going to find it as Captain tape. Very similar to PEI, and has been used for bed toppings for a long time. It's a bit more finicky to use than PEI, but it's very similar chemically and functionally. Okay, so that's that prepared, and now we can move on to actually mounting this thing onto the frame. Again, these wires are going to get zip tied to one of the struts for the of the bed undercarriage, so that we get some strain relief. These are going very closely over these zip ties right there, so I might need to zip tie these very far out, or just to the bolts that we're going to use here. Okay, switch that around. There we go. Okay, long bolts. Yeah, Ralphie, the hypercube that he built, how much did that cost you? That would be interesting to get a reference, sort of. Oh, that might just work. Yeah, the frog isn't the nicest, I do admit that, but that's not the goal. If it works, it's good enough. And time is money, and putting more time into this would have meant the thing being effectively more expensive. Okay, let's see. We are going to need a bit of space there. Ooh. That's not good. That is way too close. So we are... Okay. So what I'm seeing right now, come on, is those two bolts, as mentioned previously, they are sticking out a bit too far in the 20mm screws. If I insert them right here so that we can put a nut on the bottom and the top right there, they are a bit too short. The 25s don't have the full thread, and neither do the 30s. So let me see. Option number 1, shorten these bolts, clip them off. Option number 2, put a washer on the part down there, but then it might not slide over things as well. Might still work. Let me see. Dremel. I do have a Dremel. It's actually sitting right over there. Not sure if that's a good option, but we could. Well, the belt is in there, so we're not going to be able to get at those. Dremel maybe, yeah. Yeah, Dremel. No spaces, no spaces, just the thread of the screws themselves. Let me see, we are gonna have to go pretty far down here, so... Yeah, but that Dremel off, that should work. That's a washer and a nut, and then the bed, and yeah. Just get these screw heads off. Should I file them off? Actually, I think I've got something better than the Dremel. Let me just go get that. Drill at the top of the wood and press fit a nut in the bed. Yeah, but then I'd have to take off the belt and stuff again, so... This way. This way. Okay. Yeah, bolt cutters. The problem is the screws are short. Can't get at them with a proper bolt cutter, and just the wire cutters, the Knipex wire cutters, they are gonna dent with. Oh, actually, I could try. These are screwed in with. They're gonna dent with stainless steel or steel that's made out of is pretty tough. Okay, it's stainless. So. Ha. Okay, old Knipex Kraftzeitenschneider. What is this? The 7402. And this one this one has some battle scars, so I don't know if you're actually going to be able to see it, but this guy, I've snipped some electrical wires with this guy, like 230 or 400 volt cables with this thing, and I had asked the electrician at that point, hey, did you cut the power to these? And he was like, yeah, we're fine, whatever. And as it turns out, yeah, when I snipped that thing, the power was off, but sparks were flying, sparks were going everywhere, and obviously the whole building was out of power after that because we tripped the main breaker. But yeah, that's when the electrician is just like, yeah, we got it. So these are obviously my not sponsored by Knipex, but I just like their stuff. That were the short ones, and then I got the longer ones. And these are still pristine. These are in great condition, but these are just my beater pliers, essentially. And quick file. Clean it off. People say 3D printing is useless, but there you go. File, 3D printed grip. I've had that for many, many years. That is like 5 years old now. Someone hold that thing. And that grip has been working beautifully. That nut just came off. Okay. Apparently we do have to retighten this guy. But now, of course, this thing is perfectly flush and is not going to rub against the bed. There's one. There's two. Now M3 screws or nuts with their 5.5 millimeter head. They're a bit annoying to work with because you can't get any decent sized wrenches to grip them, and well, at least I don't have any. So I usually just use the Tamiya tools, but I've broken my last one just recently, so I don't have any real tools to deal with these nuts. Which is unfortunate. I'm gonna have to look what else I can get for that is a decent tool. Okay, so that's something you can't see. This is how we're gonna route the wires, just right over there, and then zip tie them to either just right out there. And this is not sitting on the bolts. That is good. The MDF bit is too close to the frame. To the frame? To the frame? To the bed? So if you're worried about that, let me see. Let's grab one of these boxes back here. Here we have Ultimaker filament boxes. Those suck. Have a hole in them. This also isn't fluffy. Why don't they have... Ah, that's a fluffy box. Okay. So in case you're worried about insulation between the heated bed and the frame, or the subframe, because obviously this is wood and this wouldn't have to, or wouldn't work well if it gets hot. One of the cheaper options to insulate it is cardboard. Cardboard is fairly temperature stable, unless you have a thermal runaway, which these heated beds typically don't, because they are such a high load on the electronics, and if they have a thermal runaway, the electronics are going to melt down first. You know, this stuff is a very good insulator. So, yeah, old filament box. Rigid Ink uses some very fluffy cardboard, corrugated cardboard for that, and yeah, it works very well as an insulator. Look, they even have a pre-stamped hole for the thermistor. Ta. Almost. Also not sponsored by Rigid Ink, but their filament boxes are free if you buy some filament. And the good thing is it fits the heated bed pretty much perfectly. So look at that. Or a pizza box or something. This is just an original cutout, and it's like the perfect size for the heated bed. It just fits extremely well in here. So let me just cut off the corners right there to fit the screws, making it even more flammable. Actually not. If you look at the flash point, or the self-ignition point of paper or cardboard, it is pretty high. And if you do get an open flame to this thing, I wouldn't be worrying about the cardboard. I would be worrying about the all the wooden parts on this thing first before I worry about this bit of cardboard down here. And we can poke the screws in here. Perfect. Frame too close to the bed. The nut will crush into the frame. Into what frame? Left side closest to the camera. What? Ah, that guy. Okay. I see what you mean. Both sides here. Okay. That's something I didn't consider, because how does it work on the original one? Oh, they're using like super flathead screws. Okay, so right here, let's see. So we're going to put a bolt through here, and that's going to stick out slightly, and that is going to crash into the frame. Okay, that's something that needs to be fixed. Thank you for that. Yeah, Fahrenheit 451. That is actually busted. That self-ignition temperature. As far as I know, it's not entirely accurate. Okay, so that's something that I will have to update on the frame PDF. Let's see. I think I'm just gonna cut a tiny piece out of the frame and fix that real quick, because that's like a super quick fix. For people saying, "Oh, the music is annoying." There you go. Still not sponsored by Bosch. I wish it was. Okay, so that looks good. It looks like roughly the right spot. Yeah. Yep. And same over here. Okay, now how do I get in here? Like that? Yeah, that works. Try doing this with an aluminum frame. Now we've got plenty of clearance. Awesome. Quick fix. Perfect. And because this frame is so thick, it doesn't really care about, you know, losing a bit of material there. I think that was a good solution. Thanks for the $2 tip, Ryan. There you go. Multi-tool would be better, yeah, but also much noisier. I don't really like those. Okay, frame's looking good. Someone wants to make a GIF out of that, feel free to do that. Okay, and now we can put the professional rigid ink bed insulator back on. This way around? The other way. It's in dead center anyways, isn't it? Yeah. What's that? Ah, that's the zip ties. Okay, let's poke those through as well. One second. This is looking too good. This is looking way too good. There we go. And Twitter. Tweet. It's coming along. Perfect. Okay, and the other way around. Okay, that needs a bit of a cutout for the wiring right there. Yeah, obviously down here, that's, you know, this area over here, this is wood free anyway, so it's not, well, it is gonna catch a bit of a draft, but it's not going to heat up the wood, so we can safely cut away a small section over here. Thanks for the link, Simone. Let's see. Yeah, live streaming a tweet. Yeah, I guess the most crucial skill you learn when getting your engineering degree, which a lot of people actually miss out on, and you know, that is problem solving. That is practical problem solving. A lot of the engineers that, for students that are and they were in my class. Not that I discount their knowledge or anything, but they were very focused on just theory and doing everything by the book and doing everything properly and stuff. And I guess, yeah, there is a market for that, but in reality, once you go out and actually have to start designing and engineering stuff, it really quickly stops being about doing everything perfectly, because first of all, you don't have the budget to do that, and second of all, you also don't have the time to do it. So yeah, one of the most crucial skills is going to be problem solving, and this right here, this is that exact thing. This is problem solving on the spot. 1, 2, 3, 4. Okay, so the way I'm gonna assemble this, hoping this is gonna work, it should. It's gonna need a few washers, a few more than that. And did I check the motors? Wet. And I'm also going to need a few nuts. There we go. So the idea is that the bed is going to get clamped. First of all, okay, so first of all, washer. Screw head, washer, then the bed, then another washer, then a nut, and that's just going to clamp the bed in place. Then another nut, washer, nut, that's clamping the bottom right there. Let's start. Actually, I have to install these on the bed first. So there we go. Screw head, washer, another washer. Good thing we got these large washers because these holes are like for M4 through, so they're pretty large. No springs. Springs suck. Springs for a heated bed are some of the worst design decisions when you have a moving bed. Because the only thing that they're going to do is, have your bed bouncing around back and forth. So, yeah, not a huge fan of it, if you can't tell. Then another nut, and then this is going to poke through. Wow, that's going to be really close. This guy's going to poke through here, and then we're going to put another washer and nut on that side. That is... crap, I didn't think that there was going to be that close. Nylon washers because of the traces. No stainless washers because that is still really close. Okay, I'm guessing no washer on the bottom then. But gravity. But in general, that's the idea. So a 22 screw would be ideal for this. Come on. So up here, could I take a nut out? This probably would just move it down too far. Screw head, washer to clamp the thing, then another washer on the bottom here, then a nut to clamp the heated bed in here. And then another nut and a nut on the bottom to clamp the heated bed. And that's barely adjustable. I would need a 22 millimeter screw, which I don't think I have. I've got the 25, but that one doesn't have, that's actually a 40. I've got the 25, but that doesn't have the full thread, so I can't really clamp the heated bed up here. And that wouldn't give me any extra length. So yeah, I could also take a bit off the bed right there. I could just snip a tiny bit out, and hold on, I'm actually going to do that and use that. Use the 25 upside down. That's not going to help. Yeah, quick fix. Thanks for the £5 tip, Stephen Q. Take your nuts out. Now, the corner is bent out of the box. So again, this one isn't the best, nicest, fanciest bed. But that's okay, because this bent corner right there, it's gonna get clamped between washers, so It's okay. It's okay. You can get away with a lot of stuff when building a printer like this. Including sawing out bits of your heated bed frame on the fly. You can get away with that totally. Because large washers are awesome. Again, all these things that I run into, I'll try to compress into like a build notes video that just has all these things. Yeah, you might need to file away a bit of these corners. You might need to use a bit of a thinner material, screw lengths, etc., where it deviates from the original one. Right, and that is gonna work. Thanks for the €2 tip, Moritz. Come to Menorca and leave this printer a little. Menorca? Where the hell is Menorca? Righty then. So let's try that again. These beautiful pieces of plastic are looking way too nice. Yeah. Now, people keep asking me, hey, what sort of print quality do I expect from this thing? I do expect this thing to perform pretty well. I do expect this thing to perform, well, again, maybe the hot end is not going to be as reliable as the real deal. But other than that, I do think it's going to print pretty well. I don't want to say on par with the Mark II, but yeah, maybe on par with the Mark II. Thank you for the tip, Mark. 10 New Zealand dollars. Also, one thing I saw on YouTube the other day on, I think, the very first video of this DIY build thing series. Someone commented, hey, Prusa, you capitalist pig, essentially. Why did you raise the Mark II price from $699 to $899? That's more than a 30% price increase. I was like, wait, what? Did I miss something? They're like, what? And as it turns out, the guy just confused the price of the Mark II kit with the assembled one. He originally probably saw the kit and then looked at the assembled one and was like, why is this so much more expensive? You must have raised the prices. Yeah, okay. Whatever. Okay, but that's the idea how the corner is supposed to look, and that is, yeah, that's exactly what's going to work. So this is obviously very stiff. I can bump it, of course, and it slightly moves. But this is stiff. This isn't going to move. We can clamp this nut down towards the top. We can clamp these down towards the bottom. This isn't, well, once this is clamped down, this isn't going to move back and forth. And we even get a bit of adjustability with these two nuts. So that is sweet. Near Mallorca. Okay. Again, I do need to look into like a proper wrench for this. But yeah. So yeah, these are adjustable, but I won't care about the adjustability at all because this is going to be 100% software corrected. there is not going to be any need to manually adjust them. That's sort of what Printerbot does. I don't know what they're doing on their newest Simple. We'll get one of those soon, hopefully. Just need to get back to Brooke. But they've sort of pioneered that, having the bed just completely fixed to the frame and non-adjustable, and relying entirely on software compensation. And that works surprisingly well, gotta say. Okay, that is looking good. Now we'll take this guy back out because I do want to, oh, I can swivel it out of the way, but I do want to, yep, there we go, add the screws and the nuts first on the other corners. Richard Griffiths, 5 pounds, loving the on-the-fly engineering. Budget, it works. This is, yeah. Is it proper engineering? I guess it is. The term engineering is a very wide area. Again, problem solving. Should have a metal printer to print out a 5.5mm wrench. Yeah, but what I did recently was watch the builder. What I did recently was, which I thought was very cool, very simple, but just showing how powerful 3D printing is. I mounted a new stem on my mountain bike, and I didn't have a spacer. I didn't have a proper 10mm spacer. But I do have these 3D printers that can make stuff on demand. So I just printed a 10mm spacer. Took like 30 minutes to print. From nylon carbon from the Richard and Carbonite. And put that on. Was able to ride. Awesome, awesome afternoon. That is the power of 3D printing. It's problem solving on the fly. It's the same thing as building a machine, to be honest. You get the ability to solve your own problems. Unconventionally, maybe, yeah. Who else is using a plastic spacer on a stem? But it works. It solved my problem of not being able to write that day, and not being able to try out the stem that day, and allowed me to do it. Which software did I use to design a spacer? Well, it's like a 2 circles and an extrude feature. I did that in Onshape. Just downloaded the STL and printed it. Totally works. But you can basically do anything. Or use any CAD tool. Abdullah is asking, where's the bed spring? There is none. No springs. Springs suck. I just explained that a few minutes ago. Mega Man Mike, get a couple of Hofbräu Dunkels. Yeah, thanks for the 5 pounds. That's like half a case of dark Weissbier. Would you mount the X-axis motor on the other side? What? Did I add fills to the spacer? Nope. But I could. So let's see. These are, well, these can still slightly slide around. But yeah, these do fit. And again, I just want to get them all roughly towards the to where they're roughly at the right height. That should be okay. Did I use a 3D printer to make a 3D printer? Yeah, good read for that. Check out reprap.org if one of the mods wants to post that link. And that's where it all started. That is where literally the 3D printing community revolution started. That is why we have access to 3D printers these days, is because Adrian Boyer, I never know how to pronounce that name, did have the idea to use a 3D printer to make more 3D printers. And this is one of the results of that. This is a 3D printer that was 3D printed on another one, and otherwise made in the workshop with a hacksaw, well, with a jigsaw, for the proprietary parts, or for the wooden and frame parts, and everything else is just off the shelf stuff you can buy really easily. It's not hard. It's just, you know, you do have to put a bit of research into it. Okay, I'm actually gonna open up these holes in the corners a bit more. And is this camera sagging? I don't know. Oh, the beer wars have begun. Brett age $5 go with a Franziskaner Dunkel instead. Any other suggestions? Shamelessly milking it. Yeah, of course I have been accused of just making or trying to build this printer into the ground, essentially to advertise the original kit. I wouldn't disagree that the original kit is a good buy, so a good purchase. But the goal of these videos are this build is not to make a bad 3D printer. The goal is to make a 3D printer that is as cheap as possible and uses, you know, all the cheap parts that you can get on AliExpress and the other outlets. And, you know, try to make as good as possible of a 3D printer out of them. That is looking good, and from the reflections, this thing is looking very smooth. I don't feel like I can actually comment on beer preferences. That might start a holy war between all the Germans watching right now. But I can tell that the local beer we have here is crap. It's barely drinkable. Okay, these aren't perfectly straight, but okay, this is sticking out far enough as well. Okay, let's put on. Oh, tea. Thanks for the reminder. I have some cold green tea here. But I don't really want to throw that out, so. That was actually surprisingly good. X-axis motor on the other side. Why on the other side? I still don't get it. Opinion on all metal 3D printer designs. It's sort of like my opinion on everything. If you do it right, it can work. It's the same thing, I don't want to say it, but the same thing with Delta versus Cartesian machines and other 3D printer design choices. But, you know, that there are obviously machines that do it really badly, that do the all metal thing really badly, and there are some that can do it really well. It's not a one is definitely better than the other. Got it. Is the bed sensor going to compensate a bent bed? Mario is asking. Yes. Simple answer, yes. I will use the sensor setup with a mesh bed leveling setup, which, you know, if you usually look at what a 3D printer bed sensor compensation thing does, is it takes like 3 measurements, one up front, 1, 2, 3, one in the corner, and then it calculates a plane and tries to fit that into those 3 points, which, you know, if you measure 3 points, you can totally do that. But what I want to set up is mesh bed leveling, which takes 4 by 4 or 5 by 5 measurements and then calculates a tiny plane within each of those segments. That's as far as I understand. And then compensates for each of those sections. And that's what the Prusa does, the original Mark II, with the 3x3 grid. And I'll just have to try and see how tight of a grid this machine is going to need. Oh, actually, nice side effect. To compensate for bed flatness. But it's not looking that bad. It's not looking like we're going to need like a 16-point grid. You might actually just be able to get away with a 9-point grid as well. So one of the side effects of cutting out this relief on the bottom here is that now we have place for a zip tie to go. Okay, yeah, the one design that I'm actually gonna call out as a non-feasible design are polo machines. There's not a whole lot of upsides to them, but a lot of downsides. So, yeah. That's the one I do have a strong opinion about. More zip ties, yeah. You can never have enough zip ties. Okay, now these nuts will need to get tightened up, so I'm gonna start with the top ones that hold, well, that just clamp the bed. And the lower ones can still rotate freely, so there we go, that's okay. And again, I'm not worried about these washers rubbing through the solder resist and shorting stuff out, because again, they are static, they are not moving around, they are not rubbing, and as a result, they are not going to wear through any solder resist on the PCB. Lone Tick is saying one of the upsides of a polar printer is that it can double as a turntable for a scanner. The problem is those turntable scanners, they're probably as useful as a Polar 3D printer, which is not very. If you need like super low resolution scans, then yeah. But so far, my experiences with just the rotating table scanners has been very underwhelming, like barely usable. Usually I get better results with just doing something like a 123D catch, which is just using a camera, doing a bunch of photos, and then you know, uploading them to the Autodesk servers, and that will usually make a better model than any of the turntable scanners, and it's free because literally every cell phone you can buy today has a camera that is good enough for that. So perfect to spread sauce on a pizza. That's already tightened up. But you could spread sauce on a pizza with a regular Cartesian machine as well. Nothing stopping you from doing that. Cartesian machines can move in circles. Don't need to rotate the pizza. Okay, now obviously we're screwing these down on 4 points, and 4 points, as you all know, over constrains a plane. So this thing is gonna be slightly bent, and for everyone saying, yeah, bed leveling sensors and stuff are sort of nice, but you're not gonna get accurate parts with them. Consider this: a 3D printer is, well, this one may be a bit less than others, but a 3D printer is not a tool that is like super duper precise. Just a quick test. I did do a video on calibration and why you might be doing it wrong a while back, and essentially, here's the hardware shit. And essentially, the point is, the inaccuracies that you just get from belts that don't have their steps perfect might be worse than some of the other things. So, was that the conclusion? Not exactly, but you get the idea. When you print a 200mm long part, it might come out with 201mm with 202, so 1% dimensional offset. That is one of the sources of inaccuracies. If you take a bed off the surface while it's still hot, it's going to bend, it's going to slightly warp in whichever way. If you have a part that doesn't stick perfectly, it's also going to warp and bend. Those are all things that are much more severe than the slight inaccuracies we're going to get from a bed that is auto-leveled, auto-compensated for those sort of inaccuracies. So I'm not too worried about that, and that is why I typically prefer having a 3D printer with a bed sensor than one with a fiddly manual adjustment mode. And this is actually surprisingly solid. I'm surprised. This is 1.6mm aluminum. This feels good. This feels very decent now that we have it very tight. Excuse me, on each of the corners. Okay, so this guy is going to come up like that. Because we do need a bit of strain relief. It's going to come up like that. I don't want to get it caught in the zip ties or in the corners over there. There and then, yeah. So like this. I think I'm also going to zip tie a piece of nylon filament in there just to give it that bit of extra resistance. But where am I gonna fix that? I'll just zip tie it in here, and then we're gonna see how well that works. And again, Tallman 910. Very curly, but very stiff. Can I do a review of the $99 Start 3D printer from iMaker? It's not called Start, it's called Start. It has 2 T's in there. Yes, they've gotten in touch with me. It's just I've got so many other things to do now. It's crazy. Okay, people asking about glass on top of this thing. The problem is glass does not work with the off-frame bed sensor. The bed sensor is not going to trigger against a glass top surface, and that is going to send things crashing, which is not great. Not particularly great. Will a single zip tie work? Maybe. Do I ever print with Tallman? Yes, I do. But the thing with these filaments is, like the 910, I really like the 910. It's a really good filament. I don't really want to use it on just everyday project or stuff where I think I can get away with like a PETG or even an ABS or regular PLA. Regular PLA is actually much better than you would think. So I just keep it in the box, I keep it dry, I keep it neat and tidy, and I end up not using it. I end up saving it for the nicer parts, which is a shame. But that's how it goes. That's one of the reasons why I print with such mundane millimeters for crap. I'm reading chat for such regular boring materials for a lot of stuff I do. Like I felt fancy when I was using the carbonite for that bike spacer the other day. Okay, that works. Are your zip ties the cheap Chinese ones? Yes, they are. Alex Volkov, $5 Canadian. Thank you. Asking, will ABS work instead of nylon? Nope. For wire resistance, nope. The reason why we're using nylon, or in this case in nylon copolyester, is that the nylon is just very, you know, ductile in the widest sense. Nylon will bend along and ABS will wear out. ABS will eventually just crumble and kink and break. And that's the exact property that you don't want for... Oops, that's the thermistor wire. That's the exact fan wire. That's the exact property that you don't want for... this wire guard back here. And the ABS will flex back and forth quite readily. Much more so than ABS. What's MK2 printer that's not the Prusa i3 Mark II or the Ultimaker? Probably still the Printbed Play, actually. That's like my travel printer. Because it's so simple, it's so... It sits on the shelf all day, yeah, it's literally always just back there. But whenever I pick it up, it prints. It just works. It doesn't have a heated bed, it doesn't have anything special, but it's just a great little reliable machine. I like it. I like the simplicity of it. 3D printers ever catch on fire? None of mine, thankfully. Okay, so we've got the heated bed sorted. Great. Where can you buy this nylon wire? This is just a nylon filament. You can use Trimmerline instead if you have that. That also works. Trimmerline usually is a bit softer, but also works for this sort of reinforcement thing. How easy has the build been so far? You be the judge of that. I've built one of these and many other 3D printers yet. I mean, it requires a bit of problem solving, a bit of critical thinking. But so far, if you stick to the Mark II instructions, it's pretty good. Okay, next up, power supply and electronics. We will need this guy, which we will need to fix first. An Arduino and a power supply. So I've decided to go with the original Meanwell power supply for now. Because, I mean, what I looked into was how rigid this frame actually ended up without that power supply brace. The original one has the power supply back here and then braces against this M10 threaded rod back here. Actually, let me compare. There's that, and there is the original one, which, as you can see, has the sitting on something, has the power supply right there, and then a brace over here that goes through that threaded rod back here. And this one obviously uses that power supply to make the entire frame assembly a bit more rigid. This one is a bit more floppy, but not so much, not so bad. Thanks, Simone. And I'm not going to worry about putting that brace in here right now. I might when I actually get my hands on one of those new style power supplies that the Chinese sellers sell. But now I'm just going to put that right there. And then maybe eventually, if somebody wants to design something for the... wants to design something for the power supply back here, or for some of the Chinese new style power supplies that you can now find, feel free to do that. Feel free to publish that. I was actually thinking about just making like a bracket that goes on top and a bracket that goes on bottom, and then that bracket mounts to the frame and to the power supply bar back here. Okay. Yeah, so that's going to be on this side over here. So this power supply has 2 holes, and I'm going to drill them somewhere around here. These are M4. Yes, they are. There are already a lot of covers for those on fingers. That is great. So if you want one of those, just go pick one out. I don't know if the covers. I've looked into them. I don't think they are. They actually include like that bracing part on the back that you'd need to make this frame stiffer. But if you can find one like that, no point in designing your own, obviously. I don't know how far I can screw this thing in before it shorts something out, but we'll just find out. To put it shield directly, what? Okay, dimensions, distance right there. That is 15 centimeters. And the first one is gonna go right there, right there. Just gonna go grab some wood drill bits. Double-sided tape and zip ties could work too. I think zip ties would fit the theme. But then again, it's zip ties. Yeah, the zip ties are not going to stop the power supply from sagging down. Make a paper template? Nah. Put a washer in that and nobody's gonna notice that. Well, I mean, if I do put like if I do go with a 5mm drill bit, then but you know what? Let's try the paper template. What do I have to make one? Yeah. Let's just pull that off real quick. Actually, I don't want to have this part on here either. Okay. Meta Hacker's packing slip. Perfect. Or blue tape. Wow, great. I just need 2 holes. I just need the distance between 2 holes. I should authorize links to tom3d.org. That's a good idea. Because obviously those links are never going to be anything harmful. Not now. Do it just poke through? Yeah. Boop. Boop. So, perfect template. 2 holes. I'm just going to use 2. Hoping I did pick the right ones. Yes, I did. And obviously now it's upside down, but it's just the distance that matters. Let's see. Put that through here as an alignment tool. I think this might have been slightly overkill just for 2 holes. if it gets me precise holes, then it's probably worth it. Ooh, that's not pretty. Actually, I'm gonna go through with a 5mm again. Someone was asking about the Atom 3D Proton and Neutron 3D printer designs. Maybe one of the mods can post a link. But essentially they are mostly 3D printer designs. One of them is a Delta, one of them is a Printbed simple style. Well, actually, one of them is a screw Delta, similar to the one that Shauki designed. And the other is a Printbed style machine with the extruder motor in the back of the machine. So if you want to look them up, it's a pretty crazy design. I don't think it's very practical though. Either one. So the Delta looks pretty flimsy. For my limited experiences with Deltas, I would build it a bit more massive. And the Printbed style one just looks super weird. And I don't know. I've not understood the reason why they put the extruder motor on the back. I don't think there's any real advantage to doing it that way. Yeah, and obviously, Atom, from what I've heard, they don't have an intention of selling those. They don't have an intention of making money with those. They're more or less just playground designs, is what I call them. And essentially, their engineers sort of designed them, played around with them a bit, and were like, oh, okay, this is fun, but we're never going to turn it into a product, so let's just release them as open source. That's more or less the idea behind them as far as I understand. And that's just my luck right there. Screw hole is exactly behind the smooth rod here. So there's the hole right there. You can't see it because it's behind the rod. So I'm just going to have to slightly move this thing out of the way. Both require machine parts you can't get anywhere in the West? What? Oh, it suck. There we go. Ah, the template worked. Drill and access hole through the smooth rod. I don't think that is going to work because the smooth rod is hardened and my drills aren't. My drill bits aren't. Yeah, there. Why is a Delta not a complete design? What? Okay, that's on here. That M5 threaded rod looks a bit bent. Yes, it might just be, but I don't think it's gonna matter. I don't think we're actually gonna see it. We're just gonna have to find out. Because it is M5 and because we are using those hose, yeah, those PVC hose tube couplers, it shouldn't transfer into the X-axis, but we're just gonna have to see. I think that's not a big issue with this machine. Okay, power supply is mounted. That is actually nice and sturdy in here. It's not perfectly lined up. It's okay. That is okay. So next up, other side, the Arduino somewhere over here. Someone commented, yeah, the M3 holes, if you put them through these, or if you put an M3 screw through these holes, it's not going to fit exactly, which is true, but you can jam a screw through this and just force it in. Using like, can you put a nut on the other side? Probably not, so that's going to be an 18. Yeah, so ideally you would have printed spaces on the back. So that one works, obviously. You would have some spaces on the back where this comes out. I didn't print any. I should have printed some. Do you have any sitting around? I don't think so. So, yeah, that doesn't fit, but this one does. You should have a space on it so you don't bend the PCB as you screw this down. So do as I say, not as I do. That one fits as well. So 3 screws. You know the words. 1, 2, 3. There we go. That's gonna fit somewhere around there. Yeah. So in this case, because we have that's actually the perfect width. I don't know if the i3 frame is actually designed to mount a ramps or something. That's actually designed to fit that thing exactly, but it is exactly the correct width. It's like perfect made, which is a bit unfortunate for our screw holes because we're not going to have anything for the screws to grab into unless we move over here and then risk the printed part crashing. That's not great. I am having naughty thoughts right now. Should we go with a hot glue? Should we go with a hot glue? I think we should. Chad, let me know, hot glue or not? Should I try to like do this properly, or should I just hot glue it on? Just use hot glue. There's the first answer. Do I have that guy here? I think I have that one next door. While I go grab the hot glue gun, just cast your votes. Let me know. It is hot in here. Zip ties, sky hooks, glue, hip tie, hot glue, chewing gum. Properly. It's like a really hot glue, no glue. It's like very even. Gray duct tape. Why no screws? Yeah, the screws are very close to the edge of the frame, so we're gonna need this and this screw hole over here, and if you put it like aligned on the frame, this is not gonna have anything to grab into. This frame is just gonna crack and shear out as well as this one. And if you move it further in, or if you turn it around, it's obviously the same thing. If you move it further in, we are going to have issues with the extruder wires there. And once we put the Mark 42 bed on it, you know, a print could possibly collide with it as well. Use straw pole. Simone, you should be able to operate Nightbot actually as a mod. You should be able to create a straw pole through that. If I type commands here, that should give you a link to the, if Nightbot is still awake, I'm hoping, that should give a link to the Nightbot commands. I don't know, has Nightbot left? Ah, there we go. Obviously those commands are only available for mods. Let's see. Yeah, so that link add Nightbot. Shoop. Oh yeah. Cool. Mods can vote. Hot glue, yes or no? Best vote ever. Let's see. No, yes. That is a close call. I don't think what else. Zip ties could work. Is this a close fit? No, it's not. Zip ties could actually work and look pretty decent. Can I move it outwards? It's gonna collide with the motor possibly. So it's like a 5% majority for no. I'll call that good enough. I'll call that okay. Now we're getting to 10%. Okay, so that is a no vote, which means zip ties, essentially. I don't know if that's better than hot glue, but it's not gonna fall off. The problem is double-sided tape is not really durable, and if you're unlucky, you are just you're just gonna end up with a control board on the floor instead of stuck to the printer. Where did I put my zip tie box? I do have a few more, but well, I think my longer ones are just thicker too. So thin ones and a pair connected together. And I just checked there is nothing colliding with the zip ties on the other side. What's wrong with the middle holes near the logo? So there are two there, but I don't want to rely on just two holes, I don't think. Don't think that's all I should have. Maybe because then it's gonna flop around like that. Yeah. Now this one obviously, this one you can't use for a screw. This one down here, just barely. Nah, zip ties. Zip ties. Where does this one fit through best? Probably up here. There you go, there's one. And right in here. This is probably not the first time someone has mounted an Arduino with the zip ties to a Prusa frame. But it still feels wrong. It still feels inappropriate. But boy, does it work. Oh boy. Yep. Okay, one pair of zip ties could be enough, but still wobbling around there. Zip ties and standoffs? That could also work. That is pretty hacked. Thingiverse parts? Part from Thingiverse sounds like I'd have to 3D print something, and I can't really 3D print something because that would mean stopping the stream or pausing the stream and waiting for it to finish. That's not really an option. But that actually, that feels great. That is properly on there. Snip, snip. Okay, Arduino mounted. Now the other problem we're having is actually fitting the ramps. Where did I put that? I had it a second ago. As I'm stepping on stepper drivers. That's why they call stepper drivers. Ha! Ramps, there it is. So this ramps has bent pins. This is a very cheap ramps board, again like $3.40, and these pins are just visibly bent. That's how they came. And they're not going to fit in the Arduino. Like that. Did I actually turn off the soldering station? Yes, I did. The thing is, I'm not going to be able to reheat these and realign them. Because obviously on the solder joints there is a lot of other stuff on there on both sides, and they are both bent. I will need to try to bend these back somehow, maybe with a bit of extra force. Let's see, pliers. Oh yeah, these do bend. These do bend, so that's okay. Sometimes they snap off, which isn't perfect, but these are flexible enough so that we can just bend them back. Yeah, bending them with a thumb is a problem because like as soon as they give in, you get a slip and you're probably gonna overbend them. Okay, not perfectly straight, but it might fit. It might just fit. Oh, these up here are bent as well. That might have been me. So what was I just reading about? Desolder diode 1. Let me just scroll up here. Please unsolder Kai Berens is saying, please unsolder diode D1. What's diode D1? F1, D1. Is that D1? That is not labeled. So I'm thinking that's the diode right up here next to the polyfuses. There's no other diode on here. And that is the is that a reverse polarity protection? That looks like it's going to short out the input if you connect it in reverse, right? It might do some funky stuff when the power supply is powered off. Doesn't fit in quite all the way, but I think these things are making contact. Passive voltage to the Arduino from 12 volt power under the Y stepper. Oh, that guy. Okay, 2 hour mark. Oh yeah, 2 hour mark. Where did I put my flush cutters? So I just cut that one out. Probably a good idea. Flush cutters? There they are. Take the 5 volt power on the Arduino. Oh yeah, snip off the power pin, but I think I can just cut this diode down here without breaking the capacitor ideally. Or the other way. You'll not get the power from the supply to the Arduino Mega. Yeah, that is... Well, hold on. Hold on. If you remove that, I'm not going to be able to print without a Raspberry Pi or computer connected. So we're not going to be able to use it with the LCD, which is... Nah, okay, not doing that. Not doing that. I have decided otherwise. So that's staying in. Again, it might just be... Also, we're not running it off of 24 volts. That's the other thing, yeah. Yes, it's going to have 2 supplies feeding the Arduino. Yes, it might have a 5 volt feeding back into the laptop, but the laptop ports are protected and stuff. So, yeah. Okay. We don't have an LCD. Kai is saying, but we will have an LCD at some point. Okay, let's see. Wiring, we've got a bit more wiring to do. This one over here, and then the end stop over here. And I think I'm gonna leave that one for next time, because I do have to do a few more 3D prints. It's 11 p.m. right here. Yeah, let's actually leave it at that. So really the only thing left to do is wiring. Wiring is not something I really want to start right now. It's gonna take at least half an hour to an hour to do it right. So yeah, that's something for next time. And also next time, live firmware configuration, if this RAMs actually works. I do have a spare one, which is pretty horribly modded. But yeah, live firmware configuration, that's going to be the topic for the next one, plus wiring and stuff. So yeah, thank you for watching. Get subscribed, hit the like button, because it's, you know, casual videos usually don't do that. Patreon affiliate links, someone mentioned you shouldn't put them as a bookmark, so Amazon, please don't punish me for saying that. But yeah, I'm not gonna stop you from doing it, obviously. But next one, when is the next one? Tomorrow, same time, maybe. I don't know. It's Saturday tomorrow. It's the weekend. I don't have weekends, but I'll try to do another stream tomorrow. But yeah, thank you for watching. Thank you to the mods again, as usual. You guys are doing an awesome job in making these streams possible. And thanks for all the tips that I got. That is also very much appreciated. And other than that, good night. I'm going to start a few more prints on the BCN Sigma. I'm looking forward to that. And yeah, see you tomorrow, I think. Probably. Good night. What? It's not letting me stop the stream. Okay. Now we can.